circuits and capacitors. So this was the goal of the lab, to examine the behavior of ohmic resistors and circuits and measure with a multimeter and compare experimental values to calculated values. So the findings was that the current in the 2 resistor circuit was 0.039 amps, and then the time constant for the RC circuit was 0.1371 seconds. And then I'll explain more as we go along. So this lab was based on the node rule, where the current in equals the current out, and then the loop rule was the sum of the change in potential differences equals 0. This was the electrical resistance equation. So resistance equals change in potential energy over current, and then these were the resistance equations. When they're in parallel, it's the inverse. When they're in series, it's not the inverse. So this is the capacitance equation, where the charge over the change in potential difference. So I drew diagrams for each of the circuits, and this was the RC circuit, and then this was where we measured at different points in the circuit and how it changes the potential difference, and then these were circuit with 2 batteries, 2 ammeters, and 2 resistors. So the system was the ammeter voltmeter, and then the surroundings was the circuit. So for part 1, the initial simple circuit, the predicted current was 0.0204 amps, which differed greatly from the actual current of 0.039 amps. And then this was the reversed ammeter value. This is how the predicted current was calculated with the loop rule. And then these were made of 2 batteries, 2 resistors, and 2 ammeters. So for the open circuit, same circuit, but replace the second ammeter with a voltmeter. For this circuit, the potential difference was 3 volts, and then the experimental values was also 3 volts, so it agreed with the predicted. So for measuring potential differences around the circuit, this changed a bit with it didn't support the loop rule just because of the non-zero resistance in the wires, and it also had like a potential difference in the wires. So it's not very similar to the ideal, and it did not add up to 0. So it did not support the loop rule. Just to possible sources of error. This was the ammeter in parallel, where we calculated with the 100 ohm resistor, and it increased to 0.07 amps. Because of the junctions, some encountered a resistance, but some did not. So this therefore increases the sum of the current. Then for part 5, calculating the resistance, this equation was used, as seen before, the change in potential difference over the current, and these were our values here, using Ohm's law. So for part 6, the RC circuit, this was charging and discharging. As you increase the level of the resistor, the time increased. So this was due to the longer time for the charges to move and potential differences to decrease, so longer time to reach 0 current. Part 7, determining the time-dependent voltage, determining the time constant for the RC value. So this equation was used and basically created into a natural log equation, which was graphed. I plotted natural log of current over natural log of potential difference over initial potential difference versus time. And then the slope of the plot equals -1 over RC, and I solved for RC. And here is our RC calculated value. Then the discussion, calculated resistance values are much less than the actual resistance values, just because of the ammeter was less precise. We were doing it in real life, so there were a lot of external factors that could have happened with the connections of wires, lowering the measured potential difference. A large sources of error due to lack of precision of ammeter, external effects, and timing error. In ideal conditions, the current would measure actually higher due to 0 resistance in the wires and ammeters, and so the measured current would increase. So if you're completing the lab with real circuit components using an ammeter to measure how long it takes to charge the capacitor when connected directly to the battery, like why is the measured time different? It's because the capacitor does not reach full charge instantaneously, so the measured time in real life was much greater than the predicted time. And the capacitor also has resistance that adds to the measured charging/discharging time. Thank you.